A vector A is rotated by a small angle delta theta, radians theta is less than 1 to get a new vector B. In that case, B minus A is. So we know that modulus of B minus A would be given by root of B square plus A square minus 2AB into cos theta. And since vector A is rotated to get the vector B, we can say that modulus of vector A is equal to modulus of vector B, which means A is equal to B. Therefore, we can replace this as A square plus A square minus 2A into cos theta, which will give us root of 2A square minus 2A square cos theta, which is equal to root of 2A square into 1 minus cos theta, which further gives us equal to root of 2A square will be, okay, let's A square into root of, what is 1 minus cos theta? 1 minus cos theta is 2 sine square theta by 2. So this is 2 sine square theta by 2. So this becomes A square into root of 2 into 2 is 4. Root of 4 is 2 into sine square theta by 2. We get it as theta by 2. Now, since it is given that theta itself is less than 1, and when it is rotated to delta theta, we can say that theta approaches a very small number, right? Theta approaches a very small number. And when theta is very small, we know trigonometric identity sine theta becomes almost equal to theta. So as theta tends to 0, sine theta assumes the value closer to theta, which means sine theta by 2 will assume the value theta by 2. Therefore, we can write this as A square into, oh, I'm sorry, there will be root of A square here, right? Root of A square. So root of A square will be A into 2 into sine theta by 2 will become theta by 2. 2 and 2 will cancel. Root of A square is A. So what you get is A into theta. What is A? A is nothing but magnitude of vector A. So magnitude of vector A into theta. The correct option is option C. See, it took somewhere around 2 minutes and 2 minutes and 20 seconds. But while you practice this for the exam, while you do this examination hall, what's going to happen is you don't need to explain this much, right? So you'll do fast, in a faster way. Maybe you'll skip these steps also. So this question can definitely be cracked below I would say 1.5 minutes. And of course, I did came across a silly mistake also. So that happens. Now, let us try to understand the concept behind this question. Why is it being asked here in this chapter especially? So basically this question comes from the topic vectors, which is actually taught to you in motion in a plane. Now let us see what this is about. So we'll see 2 to 3 different aspects of the same problem. Okay. So we got vector A here. And now this vector A is rotated through an angle theta in the counterclockwise direction. And what we get is a new rotated vector B. Here, what you need to understand is magnitude of vector A is equal to magnitude of vector B. Why? Because the length of the segment doesn't vary here, right? Because of the length of the segment, which is length of vector A, is equal to length of vector B. What is length of vector A? It is magnitude of A, which is A. And what is length of vector B? It is magnitude of B, which is B. So what you need to understand is that when the vector is rotated, it doesn't mean that vector A is equal to vector B. No. Why? Although the magnitude remains the same, what changes? The direction changes. So we can say that when a vector A is rotated, though the magnitude remains the same, the direction can vary, and therefore the two vectors are not equal. Well, now why am I saying this? Because sometimes we may feel that since it is the same vector being rotated, we can say that vector B minus vector A is equal to 0, and you may end up in option A. Deliberately that has given us option A also. But this doesn't make sense. Why? Because if you say vector B minus vector A is equal to 0, it indirectly means that these two are the same vectors. But in this case, these two are not the same vectors, and in fact they are vectors with the equal magnitude but different direction. Okay, having said that, let us try to understand further how will you approach this question. See, if I draw a resultant vector here and if I name that vector as vector C, by triangle law of vector addition, what is vector B? What is vector A plus vector C is equal to? See, vector A plus vector C by triangle law of vector addition will be equal to vector B, right? And when we have vector B, we can write vector C is equal to vector B minus vector A. And when you have this, we can take modulus on both sides. So what we get is modulus of vector B minus A. So what is modulus of vector B minus A? It is equal to root of modulus of B square, right, plus modulus of vector A square minus 2 times modulus of vector A into vector B times cos theta, which is further equal to root of. Now, what we need to understand here is modulus of A is equal to modulus of B. C is equal to A. So this becomes A square plus A square minus 2A into cos theta, which further we get as root of 2A square minus 2A square into cos theta. So I think it's better if I write this maybe like this. Yeah, okay. So what I can do here is I can write this as equal to, what is equal to, we can write this as mod of B minus A is equal to root of, I can take 2A square common, so it becomes 2A square into 1 minus cos theta. Now let's have a look at this identity 1 minus cos theta. See, please don't try to by heart this, try to instead be able to derive it and apply the formula. So 1 minus cos theta, I can write this as 1 minus cos 2 into, right, cos 2 into theta by 2, right, because it remains the same. Theta by 2 will be theta again. Now, what is cos 2 theta? See, cos 2 theta is cos square theta minus sin square theta. So I can write cos 2 theta as, what is cos square theta? Cos square theta is 1 minus sin square theta. So this becomes cos square theta 1 minus sin square theta, which is equal to 1 minus 2 sin square theta, and therefore we can say that cos 2 theta is equal to 1 minus 2 sin square theta. Now, if you divide this theta by 2, what we have to do is divide this theta as well by 2. Now, cos 2 theta by 2 will become 2 by 2 will become 1. So, cos theta will become 1 minus 2 sin square theta by 2. And we will now take this expansion into here. So, what do we get? We get that root of B minus A is equal to root of 2A square into, what is 1 minus cos theta? 1 minus cos theta here is, sorry, what is cos theta? Cos theta would be 1 minus 2 sin square theta by 2. So this is further equal to root of 2A square into 1 minus 1 is 0, minus into minus is plus, so this becomes into plus 2 sin square theta by 2. So this is equal to root of 4A square sin square theta by 2, which is further equal to 2 into A into sin theta by 2. So basically we can say that if a vector is rotated at an angle theta, the difference between the two vectors now is equal to 2A sin theta by 2. Now, as I said earlier, as theta tends to 0, sine theta tends to theta, and as theta tends to 0, cos theta tends to 1. So this is one such logical relationship we need to know throughout these questions, wherever trigonometric identities comes into picture. So we can say that if theta here is given thus, theta is less than 1, right? So delta theta will be even less than 1, which we can reasonably assume that theta is almost equal to 0. So when theta is almost equal to 0, what is sine theta equal to? Sine theta is equal to theta. In which case, what would be sine theta by 2 equal to? Sine theta by 2 will be equal to theta by 2. Which means instead of sine theta by 2, we can write here that this is equal to theta by 2. And further 2 and 2 will cancel. So what we get is mod b minus a is equal to, what is a? A is magnitude of vector a into theta. Okay. So that was the concept in detail. Now, since this question is based on vectors, let us try to understand the logic in in one more way. So let us say we'll start from here. So what is vector c is equal to? Vector c is equal to vector b minus vector a, right? So vector c is equal to vector b minus a. Let us, okay, so it's primarily vector c is equal to vector b minus vector a, and therefore modulus of c will be equal to b minus a modulus of b minus. Okay, let us not do this with modulus. Let us try to do it use dot product. So once again, to start fresh, we know that vector c is equal to vector b minus vector a. Now what I'll do is I'll take dot product on both sides. So squaring on both sides, what do I get? Vector c dot vector c is equal to vector b minus vector a dot vector b minus vector a. So what is vector c dot vector c? We know that this is equal to modulus of c, right, into modulus of c into cos theta, which is cos 0. Why? Because the angle between vector c and vector c is theta, which is equal to 0, which is equal to. Now let us be more careful while we expand this. So this will become vector b dot vector b, okay, minus vector b dot vector a minus vector a dot vector b plus vector a dot vector a. Now if you have confusion in understanding the concept, it is very simple. See, what is vector a dot vector b is equal to? It is equal to modulus of vector a into modulus of vector b into cos theta, where theta is the angle between these two vectors. Now what is the angle between vector a and vector a? See, this is vector a. If you keep one more vector a on top of it, the angle between these two vectors is 0 degree, right? Which means if you were to find out vector a dot vector a, this would be equal to modulus of vector a into modulus of vector a into cos theta, which is cos 0. Now what is modulus of vector a? It is a. What is modulus of vector a? It is a. What is cos 0? It is 1. So what you get is a square, right? So by the same logic, we know here that modulus of vector c, it is c. What is vector c? C. Cos 0 is 1. Now what is vector b dot vector b? It is modulus of vector b into modulus of vector b into cos, what is theta here? Cos theta is 0 minus, what is modulus of, sorry, what is vector b dot a? It is modulus of vector b into modulus of vector a into cos theta minus, what is vector a dot vector b? It is modulus of vector a into modulus of vector b into cos theta plus, what is vector a dot vector a? It is modulus of vector a into modulus of vector a into cos theta. What is theta? Angle between one vector and the same vector is 0. So c into c is c square. Modulus of vector b is vector b. Modulus, sorry, is b. Modulus of vector b is b into cos 0 is 1 minus b a cos theta minus a b cos theta plus a square. So we can write that c square is equal to b square plus a square minus 2ab cos theta. Now since the vectors are rotated here, we know that modulus of a is equal to modulus of b, which means a is equal to b. Therefore this becomes c square is equal to a square plus a square minus 2a square cos theta, and the rest follows the very same. So we can write here that c square is equal to 4a square into sine square theta by 2, and if you take square root on both sides, what do you get? C is equal to 2a sine theta by 2, and what is c? C is modulus of vector c. So modulus of vector c is equal to, what is a? It is 2 mod vector a into sine theta by 2. Now what is modulus of vector c? It is, by triangle law of vector addition, vector b minus vector a. So this is one more way of looking at the question. And well, I think yes, there is another way to, another concept to explain here, which is actually the concept of rotation of vectors. Rotation of vectors and the concept of rotation metrics. Which I don't think is applicable in this chapter, but it may help you in it may help you in your maths, or maybe in higher mathematics, or let's do one thing. Let us try to understand that concept also here. So what we'll do here is we'll try to understand rotation of metrics. Rotation of metrics. Sorry, not rotation of metrics. Rotation of vectors. So say you have a two-dimensional axis here. Let us take it as the xy plane. Right, xy plane. This is the origin. There is a vector here. Okay. Say this is vector a. This is vector a, and the vector a makes an angle. The vector a makes an angle, say alpha, with the x-axis. Now if you rotate this vector a at an angle theta counterclockwise, this is where the new vector comes, right, which is vector b at a different angle. Okay. Now see, this discussion is definitely not related to the MCQ we are talking about. It is not at all related. Well, it is based on this, but the MCQ asked is not specific to this. The only reason why I'm discussing it here is to make sure that you just come across this. Maybe this will become helpful in solving some questions later. All right. Now we will study these two vectors in detail. Okay. So say what is vector a? Vector a can be written as ax I cap, right, plus ay j cap. Similarly, what is vector b? Vector b can be written as bx I cap plus by j cap. And what is ax? Ax is a into cos alpha. What is ay? Ay is a into sine alpha. You may have a doubt here. No worries, we'll clear that. See, this is vector a, right? This is alpha. So if you resolve this vector into two components, what do you get? You get this as ax and ay. If you draw a triangle here, this is ay, right? And then the rest is clear. So if you take sine alpha from here, what do you get? Sine alpha is equal to, sine alpha will be equal to ay by a, and therefore ay is equal to a sine alpha. So a very basic one. Similarly, what is bx here? Bx here will be equal to b cos alpha? No, bx here will be equal to b cos alpha plus alpha plus theta. You may have a doubt here too. Let us resolve that portion also. So this is vector b, right? And what is the angle vector b is making? Vector b is making an angle of alpha plus this angle theta. So the complete angle is theta plus alpha, right? So what is by is equal to? By will be equal to p into sine alpha plus theta. Now, having these two written here, let us try to go further. So I can write vector bx as b into, right, b into cos of alpha plus theta, which is equal to b into, what is cos a plus b? See, cos a plus b identity is cos a cos b minus sine a sine b. So this can be written as cos alpha cos theta minus, within brackets, minus sine alpha sine theta. And if you take this inside, what do you get? What you get is b cos alpha, right? B cos alpha into cos theta minus b sine alpha into sine theta. What we need to understand here is modulus of vector b is equal to modulus of vector a is equal to b, which is equal to a. So instead of b here, what can I write? I can write here a. So this becomes a into cos alpha into cos theta minus b will be replaced by a into sine alpha sine theta, further equal to, see, ax is equal to a cos alpha. So instead of a cos alpha here, what can I write? I can write ax. So this becomes ax into cos theta minus, see, ay is equal to sine theta, and we have sine alpha. So we got a sine alpha here. So instead of a sine alpha, what can I write? Ay. So this becomes ay into sine theta. Going on further. Okay, so bx can be written as ax cos theta minus ay sine theta. Now, what can we write similarly for by is equal to? See, by will be equal to b into sine alpha plus theta. Now, what is sine a plus b is equal to? Sine a plus will be equal to sine a cos b minus cos a sine b. And therefore, this can be written as b into sine alpha cos theta plus, what we get is plus Sin A cos B plus cos A sin B. So plus cos alpha sin theta. So if you multiply this further, what do you get? P into sin alpha cos theta plus P into cos alpha sin theta. This is further equal to. Now we'll do the same replacement. What is B? Instead of B, we can write this as A. So this becomes A sin alpha cos theta plus A cos alpha sin theta. Now, what is A sin alpha? What is A sin alpha? A sin alpha is AY. So this becomes AY into cos theta plus. What is A cos theta? Sorry, A cos alpha. We know from here that A cos alpha is AX. So this becomes plus AX into oh, this is sin theta here. Sin theta. And what is all of this equal to? This is equal to Py. And if you try to understand this two alone, these two equations separately, I think I should write it down once again, right? Okay. So let us write these two equations here. So you got Px is equal to, right? Px is equal to Ax cos theta minus Ay sin theta, and similarly By is equal to Ay cos theta plus Ax sin theta. Now let us see the significance of matrices and determinants in physics. Okay, what I'll do is I will convert this equation into the matrix form and I'll write this like this: Bx By is equal to, right? Bx By is equal to a matrix which is of much significance in mathematics. Matrix given by the angle cos theta minus sin theta wait, am I writing any mistake here? Oh yeah, yes, because this should be the x component, right? This should be the y component. Okay, so what we should write here is, all right, plus sin theta, the y component is cos theta, whole into another matrix which is Ax Ay. And if you find the it is this matrix what we call as the rotation matrix. And the beauty of this is, find out the determinant of rotation matrix. Rotation matrix is denoted by r theta. If you find the determinant of that matrix, what you get is cos square theta minus sin square theta, and therefore determinant of r theta is equal to cos square theta plus sin square theta, which is equal to 1. So we pushed ourselves a bit beyond physics, and I would say this is classical mathematics. Anyway, I had to say this much only because of the fact that the question specifically mentioned rotation of a vector. So it was not given to us whether it was clockwise, whether it was counterclockwise, or it is in the xy plane. But see, it's always good that you learn. If you push yourself beyond one step beyond the question, you tend to learn more. So maybe this becomes applicable somewhere else. All right. Now, having said so, let's move on to the next question.